Hello everyone, my name is Savan and I am an embedded software engineer at iWave Global. In this video, I will be explaining you about Remote System Update. Remote System Update RSU is a feature that allows FPGA device to be reprogrammed with new image without requiring physical access to the hardware. Instead of manually connecting the programming hardware, firmware updates can be delivered remotely over interface such as Ethernet or other communication channels. This enables bug fixes, feature enhancements, and security updates to be deployed efficiently while keeping the system operational and significantly reducing the maintenance cost. In this video, I will demonstrate the complete remote system update workflow on the Agilex 7 platform. So this is the Agilex 7 dev kit and I am using the 15 volt 22.7 amps power supply, and this is the UART that I've connected, and I'll be using Altera's USB blaster for flashing the initial RSU image. We'll cover the complete RSU workflow in 3 parts: creating the RSU image, generating flashable application images, flashing the application image while demonstrating image switching and automatic fallback. By the end of this video, you'll understand how RSU enables reliable in-field FPGA updates without requiring the entire QSPI device to be physically reprogrammed. Let's get started with creating the RSU image.
So I will go to my files, projects, and remote system update. I have created a folder structure like this for ease of understanding. So I will be using 2 application images for this creation. So this is application image 1 and this application image 2. Each application image has its own SOF file, unique SOF binary files, so which will be added as a partition in the RSU image. So this will come to this images folder later in this video. So similarly, application image 2 has its own SOF file and the binary files. And this is a documentation which walks through the remote system update RSU image creation. So I'll be referring to this document in the video. And there's factory image. This is the image that will be used as a default image when both the application image, any one of the application image or both the application image fail during the boot. And I have created another folder for the generated RSU image. So we'll be generating the RSU image now. So I will just copy the path of this folder, and we'll need Quartus Prime Pro edition for creating the RSU image. So I'm using Quartus Prime Pro 24.2 version. Let us go to Files, Programming File Generator. Let's select the device family. I'm using Agilex 7 right now, and active serial mode. And let me copy the path here. I will name this as G43M. Since I'm using HPS first, I will be ticking this, and I'll also need the jig file for flashing. So let's now go to the input files tab. In the input files tab, I will start with adding the factory image bitstream. I will go to the factory folder and add the bitstream. I will add the corresponding hex file for the factory SOS. Similarly, I will add the bitstream for the application image 1 and application image 2. And add the corresponding .hex file. And finally, I'll add the bitstream for the application image 2. and I will add the corresponding .hex file for this as well. Now let's start adding the raw data. First, I will add the factory image raw data, that is this uboot.factoryimage.bin file. Make sure that you swap the bit here. Similarly, I will add the raw data for application image 1 and application image 2. Bit swap this as well. Now for application image 2, bit swap this. Now let's go to the configuration device tab. I will add the QSPI image part number here. I'm using MT25QU01G part number as my QSPI. Add this. This will create a default partition like this. So I will go inside the boot info. So here I have an option for direct image, factory image fallback. I am not using this. I will not be using this. What this does is, if the application image fails, it will directly boot with the factory image. So I will not be taking this. Let's go to factory image, edit. I will add my bitstream 1, which is a factory image, and select the address mode as block and update the end address. I will set the partition size as 64 kilobytes. I will add partitions for application image 1, select the page as 1, and address mode as block again. Now select the application image 2, page as 2, block 02. Now let's add the binary partition. For the binary partition, for it to match with the corresponding source file, please name the binary file with the suffix FSBL dot factory underscore image for factory image, and set the address mode as auto. Again, for application image 1, SSBL.P1, and for application image 2, SSBL.P2. Now let's select the flash loader. I will be selecting the device sample, which is Agilex 7, and my device name is AGI B027R31B. We'll select this and finally click on generate. Generating the RSU image will take some time, so please wait for some time until the image is generated. Now the programming file is successfully generated. We'll go back to the folder. We'll see that the RSU files are generated. There's a zip file which will contain all the partitions, and these are the corresponding RPF file for each partitions. So the next step will be flashing this zip file.
Thank you for watching the part 1 of the video. We have now successfully generated the RSU image. Stay tuned for the part 2.